Hi everyone. Today I would like to welcome you to our 13th Artist Masterclass. Today we're actually going to pull in a few different things from previous sessions as well, including shader authoring, lighting, reflections, and a few other things. And the ultimate goal is going to be we're going to build a water system, specifically for doing ocean rendering, although I'm sure we can adapt some of this towards things like rivers and other kinds of water bodies to your heart's content. Today we're going to be focusing heavily on shaders. Specifically, we're going to be rebuilding one of the shaders that comes with Unity. So to do that, we're actually going to start with the Waterfall Shader. That actually is included in the editor packs that you've got available. It's a Unity standard asset. It's a little bit old. It actually predates Unity's PBR, physically based rendering pipeline. So it actually renders things in a quite old way. So we're actually going to rebuild it from scratch. Well, not from scratch, we're going to integrate parts of it, but overall we hope to produce something that's going to be a usable, workable water system that looks good, renders nicely, and is free. I'll post a download link to the finished shader when I'm done with this class. Hopefully we can get it finished up to a point that it's useful to some people, but we'll sort of have to do a bit of trial and error today to try and get it looking the way we want it to. So I'm going to release my screen here, and we've got our test scene that we've been using for the last 3 weeks. There's no harm in reusing this one for today. All the work we're going to be doing is going to be outside the play mode because we're just going to be testing the shaders directly. Now, the reference image that I pulled up for what I'd like the water system to look like is going to be basically looking like Bora Bora. So something equivalent to this, where we've got deep blue oceans further out and then sort of a light crystal clear reef close up. We'll be able to tweak this further on. What we're going to do is we're going to play around with the depth shaders. I'm going to need to look up a few things as we go along just because this is a little bit out of stuff that I played with recently. But overall I hope to sort of get a similar look from the Waterfall Shader. Now, to get started on the Waterfall Shader, I'm just going to pull it up and give you a quick example of what it looks like. If you just search for Waterfall, you'll see that it's in the editor packs. This is named because it's the water system from Unity 4, which, as you can tell, is quite old. I think this is probably 4 or 5 years old, this water system. So it once upon a time looked fantastic compared to other assets, but today not quite so hot. There's a few big problems with this water system from a modern rendering angle. The first is that it does do reflections, but it uses what's called Planar Reflections. So Planar Reflections, as you can see here, we've actually got a separate camera in the scene that's been added by the Waterfall asset that's actually flipped upside down, and that is used for rendering the whole scene twice and then pasting it onto the water system. As you can see, you get quite nice, crisp, accurate reflections, but the downside is it requires rendering the entire scene again. I have mentioned this in a previous tutorial where we discussed some of the things we did with the Welcome Center when we did its update. Now, what we want to ideally do is actually switch towards a reflection probe based system, because we've got reflection probes in this scene. If we pull up our sphere and we'll attach a metallic material to it, we'll be able to see what those actually not a sphere, cube. Sphere, there we go. So if I grab this one, put a metal on it. Now I might need to rebake my reflection probes. No, I don't. Okay, so as you can see here, we've got a reflection probe in the scene that's sort of giving us some reflections that are on here. We can play around with the smoothness and things on the normal materials to sort of determine how reflective it should be. However, we are going to use that and many other things in the production of getting our water reflections and things looking right for this replacement shader. Now, as I mentioned, this one's not a physically based shader, so that means that it's not going to respond to lighting very well. If we change the day-night cycle in here, I'll just pull this one up that we put in before. If I enable previews and go through scrub through the day and night, you're noticing something here, and that's that the water is not really responding to lighting very well. And that's because it's not a physically based shader. Now, the big difference between what's been done before in previous generations of games and virtual worlds and other engines has been that the shading has been computed for a particular lighting setup. And that's fine if you're authoring towards particular ideas, you bake in the lighting that you're looking for, that kind of thing, but when you actually start dramatically changing how the lighting acts in a scene, for instance, a day-night cycle, the older way of doing things sort of falls apart. Again, as I'll just show you, it sort of doesn't look very good comparatively to everything else. What we're going to do is we're going to pull apart the shader file that's included. In Sciencebase, you can edit whatever shaders you'd like. You can upload your own custom shaders as part of the materials, and that's exactly what we're going to do today. So I'm going to pull up the shader. Now, there's two variations of this this Waterfall Shader. If we go look at the materials, you'll see that this is using FX/Waterfall, but there's also Waterfall Simple, which is Simple Waterfall, there we go, which doesn't have the foam texture. I'm not 100% sure we will actually keep that feature. It's one that I find actually doesn't tend to look very good, but we'll see how we go. It'll depend on sort of how much time we get towards all these various features. But the first thing I'm doing is I'm going to pull up the Waterfall Shader, which I have here. Now, I'm just editing this in Visual Studio. You can use whatever application you like. Unity does provide Visual Studio code highlighting and syntax highlighting for shader editing. Now, this is all written in a language called CG. CG is a derivative of C. It's actually a subset of both HLSL and GLSL, which are the standard shading languages that are used almost everywhere. And basically, by the benefit of being the subset of the both is that you can actually then recompile CG for each of the various platforms. So if you've got OpenGL clients, they use GLSL, whereas if you've got DirectX clients, they use HLSL. And there's various versions and things between them. So CG is a convenient intermediary language that can compile between them effectively. And Unity provide a few other cross-compilers and things for various other platforms, like Metal and things that will be supported sometime in the near future. Okay, so let's get into the down and dirty of how this works. This shader is not written as a surface shader. Again, if you watch the shader tutorial, we discussed the differences between the two, where the surface shaders provide a lot of outputs for us automatically, so we can just specify things like how smooth or how metallic a material is in our shader, and Unity will do the hard work of working out exactly how that should render in a PBR environment. We are definitely going to do that because I do not feel like digging into Unity's rendering and trying to copy those things. Frankly, they've done the hard work. There's no reason for us to reinvent the wheel, so that's exactly how we'll do it. This one, however, is not. And the way you can tell is that it's actually written as a half-4 frag, which means that the fragment shader, that's what the pixel shader, the one that actually renders each pixel, that pixel shader, it just returns a single color value, which is a dead giveaway that it's actually just calculating the color from lighting, but everything else is sort of completely custom. What we're going to do is we're going to take some features of this shader we like. So, for instance, the fact that the vertex was move up and down, that's been done in the shader. Those sorts of things we will pull out because we do like them. But other bits, like exactly how it renders various colors, we're not going to use. Some of the more complicated bits we've got, such as, for instance, the underlying depth shading. So there is actually a depth fog component here, which we can edit if we find the material. Here we go. There's an auto blend parameter here. You can actually sort of see, we can set exactly how transparent it gets at varying underneath heights. We're going to probably have to do a little bit of work in order to be able to tint those colors on exactly how that works in a sort of a PBR-ish way, because what we're doing is not going to be strictly pure PBR, but as long as we can get a similar looking effect and it responds to lighting, then it doesn't really matter. Okay, so we're going to pull out the bits we like, and we're going to get started. So the first thing I'm going to do is I'm just going to add a new shader, and I'm going to do it in the same directory that the other one is, and that's because it has an include file, and that's got a bunch of library components which we are going to use. So the first thing I'm going to do is I'm just going to go create shader, standard surface shader. And that means it's using the Unity standard lighting model, which is what's the PBR lighting model. So I'm going to call this one Waterfall B, or actually we'll call it Waterfall Plus. Effectively, this is a rewrite. In fact, I'll even rename it. I'll go to Water 5 just because it's built for Unity 5. Makes more logical sense. Okay, there we go. And the second thing I'm going to do is I'm just going to copy and paste my material onto these half these water planes, so we can do a sort of side-by-side comparison of how they look. So first things first is I'm just going to pull these. It's got a bunch of custom scripts on it. I'm just going to pull them off so they stop feeding in shader variables that are going to mess around with what we're doing. There's no harm in doing this. I might leave the Gerstner displacement on there, but I'm going to take the planar reflection off, specular lighting, and the water base. Yeah, apparently we need to keep that. Okay, so we'll have a look at the Gerstner display script and see if we actually need it. Okay, let's may displace. Okay, well that's pretty straightforward. It's just changing a shader keyword. Let's get rid of that. Okay, so in order to be able to get our displacement back on, I'm just going to put it on half these guys. These are the two that are going to be our basic versions. Actually, I can't do that. Alright, we're going to leave that alone for the moment. I will toggle the shader keyword on manually inside the shader, and we can actually do that straight from Visual Studio. Ignore that. So, where are we? We have our shader keywords. Now, for something that toggles on and off, it's usually done as a pragma multi-compile, which is the statement we're looking for in here. We just need to hunt around to see where it is. Are we looking at the right one? Yes. Okay. Might be in the includes stuff. What a vertex displacement. There we go. Oops. We are just going to make that happen. Okay. We're being naughty, but that's fine. Okay, so now we've got our displacement back on. That Gerstner displacement is actually a fairly well described algorithm for describing the pattern of which way waves actually move. It was from the 1800s. Most of physically based rendering and modern rendering is actually derived from physical algorithms that have been worked out by scientists many years ago. But first things first, we are going to grab half of these and we're going to switch their material. So I'm going to grab my Waterfall Advanced, I'm going to copy it. We're going to switch it over to our shader. And there's a few things we're going to try and play with here in terms of what we do here. I'm going to try and implement a few of the things that we cheated when we did our water for the welcome area, which I actually have open right here. If you remember the welcome area, we actually built a animated and I think relatively nice looking flat water system from the standard shader. If we go dig it up, you'll see here that it's actually where are we? Sorry, 1 second. Not you. Oh, where's my water? One of these. Here we go. So we've got our water, which was just built using the standard shader. It was set transparent and given a fairly smooth value. And the benefit of that one was that we got to take advantage of all the reflection probes and things that Unity's built-in system gives us, and we can sort of tweak and control. But this one just had two normal maps that animated on an alternating pattern. So we had one moving left and one moving right at different speeds, and that gave us sort of a nice tiling effect on the normal. We're going to do the same here. We're going to do the same for the actually we won't use the albedo material. We might, if we do the foam material, we will. But for this, we won't. And the other things I'm going to try and do is get some tinting and things in place on the depth height. That will be the starting point of our shader. So, I have cloned the material. I'm going to drop this one on this half, and this way we've got two halves. Whoops, two halves. Now, we're just going to swap over to our new material. I'm just going to rename it, what would we call it? Water 5. It's just going to show up in the custom list when we select that material. To start with, it's going to do very little. It's going to be probably white and have no real configuration. It'll show up in custom, water 5. There we go. Okay. So this is just the standard texture that was actually on the material there. To get started, the first thing I'm going to do is I'm going to write a Vertex Shader, and to do that, we're going to add that displacement. Now, I'm just going to quickly Google for Unity, the reference. So if you go Unity 3D standard shader examples, it'll actually pull up the cut and paste templates that you can use for placing a vertex block in here. And that's exactly what I'm going to do. So I'm going to go hunt down until we find the vertex one. There we go. Okay, custom data. Normal extrusion with vertex modifier. And you can see there we just got the vertex function. That's what I'm going to cut and paste into here. So just above the surface shader, which you can see is void surf, I'll just paste this void vert, and that's a function in the shader that'll run and return basically modifications to the vertex, or even we can sort of convert and do some calculations per vertex rather than per pixel. And we have in the Waterfall Shader, it actually has a Vertex Shader as well. As you can see here, there's a couple of versions. We're going to go with the high quality version. It's medium quality, and where's the high quality? Here we go. So this is the high quality Vertex Shader they're doing. Now we're going to go poke and cut and paste, and I'm going to pull parts that we don't need. Okay, now there's going to be probably a few things we poke around here, but next thing we need to do is just bring in this include file. So this is the water includes, and that's just got all the Unity's own water functions, and including the Gerstner displacement, which is what's doing the waves. No need for us to reinvent the wheel, so I will just include it as part of the shader. So there we go. There we go. And now I've got the water include. Okay, so we need to have a look at how this is working. Fairly straightforward. So here it's grabbing the world space position. So that is, it's grabbing the vertex position and then converting it into world space. That means the actual world coordinates rather than local coordinates. It's presumably doing that just to make sure we've got a consistent tiling when you sort of grab multiple of these and you lay them out in a grid. Okay, vertex animation. Yep. So this is all relating to how it animates things. So here's the magic part, the Gerstner displacement, and it's actually got two outputs. It's got two out variables there, which is the normal and the offsets. Now the normal needs to be changed here too, and I'll show you why actually as we go. So in fact I am going to even cut that out. Where's the normal bar? So we actually have no normals here because we're going to have to add them, but we'll put that out. Okay, so there's our basic Gerstner displacement, and with a bit of luck, we might be missing a bunch of variables. In fact, we are. Sorry about that. I've got a bunch of shader errors if I look at the bottom of my warnings. So the reason that's all come out white and things is because it's referencing a bunch of variables that don't exist. So I'm just going to cut and paste those from here. And those are the Gerstner intensity values and things like that. So we'll just cut and paste those into our property block at the top. And we're also going to grab the associated declarations, which look like they're all here. I don't have a Gerstner intensity here, but it looks like it's just a float. So I'm just going to paste those in here. Okay, and we're going to Gerstner intensity, so we'll just float Gerstner intensity. Let me just quickly reorganize that. Okay. Alright, so that should cover that, and that should now compile. With some luck. Okay, we haven't quite got this. I'm just going to select the shader. Weirdly not showing an actual error. That is unusual. Normally it would throw a fault. So we're just going to have a quick look through here and see what I've done that's incorrect. In fact, the reason why it's not working is a very obvious one. And I've double declared that one. the reason that this is not working is I actually haven't specified that we're using the Vertex Shader. So I just put Vertex Vert here. Still not. Let's just have a look at the compiled shader. Unexpected lines. Unexpected identifier on line 55. Usually it shows up, not always. Okay, so we're actually not using that V2FO, and I bet that will make it behave. A second, there we go. So now we've got our shader, and as you can see, it's now bouncing up and down as it should. So we've got a bunch of configurable parameters on here that will determine things like the wave amplitude and all those things. Up to you to configure that, but that's the first step done. Next thing we need to do, we need to make this transparent. So the first thing we do is we change the render queue and the render type. So the render queue determines what order things are rendered in. Opaque objects always need to be rendered first. So I believe it's just queue. Sorry, one second. Clear some desk space here so I can actually use my mouse. There we go. Okay, queue, and I believe it's equal transparent, capital T. And we'll set that to transparent as well. And finally, that actually should be, it's alpha fade. It's for plain transparency. Give that a second to compile. Now this doesn't actually have any alpha to it yet, but as we do this, we now actually have transparency implemented in the shader. So one step down. Next thing is the smoothness. Now, I think that if we want this to be quite reflective, which I think we do, we want to make it quite smooth. Now, if you remember from the earlier lighting tutorials, we discussed that reflectivity is a direct property of the smoothness. The more smooth an object, the more direct the rays, the more parallel the photons will be when they travel in the directions to your eye or a camera. Same principle, so the smoother it is, the more reflective it is. That's the main thing you need to remember. So to do this, we do have some parameters on here we can configure. It's convenient. So, as you can see here immediately, we're now actually reflecting off the reflection probes. Now, reflection probes aren't perfect for reflection because they do sort of, as you see, wander around like this a bit. You can get around that a bit by using something called box projection on your reflection probes, and I'll just quickly demo that one. So I'll grab all my reflection probes here. I think I can set them to box projection. And when they're in box projection, it'll actually do what you're looking for. There is a price to box projection. Both it is slightly more render intensive, I believe. You will want to double check that fact. And the second thing is it's not quite perfect. It will still sort of warp things around a bit, but it will give you that sort of parallax projection that you're looking for. Now we can get away with the reflections not looking quite so hot if we lower the smoothness a bit. Nothing in real life is perfectly smooth, but if we do it like that, we've got some reflections sort of popping in. So you can see that there's clearly something reflecting, but it's not quite there. Now, one thing we've noticed here is the lighting is very flat. If you compare it to, and I'm just going to make this not metallic. I'm going to lower this brightness as well. Actually see some of these reflections. Okay, so something you'll notice here is that this one, it's kind of harder to notice without looking for it. But the normals, that is to say, the direction of the surface, this one is changing as it animates, and that means that the light is moving a little bit left to right. So you can see, for instance, around here, it's not perfectly smooth. It's following the wave. Whereas here, it's kind of looks like it's completely flat. If we didn't have the bits on the edges and the distortions of the texture, we would not know that the surface isn't completely flat. And that's because we're not playing with those normals. As I said, I mentioned we would get to that. So go v.normal.xyz equals normal, and that's coming from the Gerstner displacement that actually calculates a normal. And with luck, this should look a bit more realistic. See, there we go. Now we've got the normals in place. So this is immediately looking tons better. Now, still not quite what we want, but we're getting there. I mean, altogether, this is looking better. So the next thing we want to do is add in support for a bump map. So to do that, we just need to cut and paste the texture declaration there, which is main text, and we will use the standard name. This is up to you to use these standard names, but it's generally a good idea, so we'll just call it bump map. We'll put this normal. And we will declare a sampler. A sampler is basically what reads the texture on the graphics card itself. So it just tells the graphics card, get ready to grab that texture from its memory. And we will finally get the normal details. So, to get normal details, you need to do a few things. The first is we need to read the texture. So the first thing, I'll just grab half for. Now, just for reference, there's a couple of data types here. If you're a programmer, you'll be immediately wondering what a half is, what a fixed is. Fixed is 8 bits worth of data, half is 16 bits, a float is 32 bits of data. So sometimes precision matters. On normals, I find precision can matter. For colors, fixed is fine. 8 bits per pixel is more than what the texture's got, so unless you're doing anything particularly fancy, fixed is fine for colors. Half I usually use for normals and directions and things. If you see something funny, go ramp it up, but basically look for the lowest you can. Now on PC desktop cards, generally speaking, everything will run 32 bits regardless of what you specify. Very few of the desktop cards will actually even optimize for those lower bit precision because all the hardware is optimized for 32-bit. But if on mobile and various other clients, it will actually take advantage and use the lower values, and it kind of can improve your performance a bit. So we're going to go normal here, so we'll go normal, and that's going to be equals the unpack normal. Now this is a function that's built into Unity for unpacking normal maps. Now normal maps are actually compressed in a particular way. It gives them higher precision, but the downside is that you have to specifically unpack them. You can't just use the texture directly. And then we finally just do the text2d function to declare it, so we'll just go to bump map. And we're going to reuse the main text UV coordinates for now. We're about to modify that one, but I just want to get this in. So I'll just specify the o.normal. And I think actually the normal, let's see, like a half 3. Let's see what it complains about. Useful having these Unity ones up because you can actually just take a quick look at what they've done. So they've just unpacked directly into the thing, so I'm not 100% sure what data type it's returned, but if it doesn't throw an error, it's usually safe. Okay, so we now have room for a normal map, and we're beginning to get some detail onto this one. So the first things first, I'm just going to test this. I'm going to I'll move the normal map over time. We're going to use 2 normal maps here in a minute. So the first thing first, we're just going to add equals plus float 2. This is for a pair of floats, which is what UV coordinates are specified in. And I'm going to go use one of the magic variables called time. I'm going to use time.z, time.z. And this should just scroll evenly. Oops. Over time as we go. And I may have screwed that up. Let's have a look at that. Okay, so 85. What did I do? 85, I may have misplaced something. Yes, insufficient brackets. Okay, so now you can see that the normal map is rather psycho, but that will do for at least the proof of concept. We'll add some speed parameters and things to this in a moment, because we can actually add a pair of conflicting normal maps that will give us the sort of the ideal effect. If you remember in here, we used the same effect on the animation. You can see that we've got that runs from 0 to 0 to that one runs to 4, 4, 3, and -1, -2. We'll use the same values here because these values actually are liked quite a bit. and also the tiling values are a bit different. So the first things we're going to do is I'm going to add 2 normal map slots, just out of curiosity in case you want to use 2 different maps. I'll just give it bump map 2. No real reason not to, and I'm just going to start declaring the UV coordinates, just so you can edit it in Unity and get the values you want. So bump, and we'll go. I guess now we've got that one, and we've got, so we go UV, bump map, and we're going to go with level 2 as well. Map 2, bump map 2. Now, these time parameters, I'm going to let you modify them. So I'm just going to declare 2 vector 4, which is going to have both parameters in it. So I'm going to go float 4, normal speed. I'm just going to declare this one up here. Normal speed. This is just in the naming, so you can see it. Okay, and it'll be a vector. It'll give us 4 parameters. 1. Okay. So we've got the normal speed there, and this, I forget exactly what the time values translate to. We can look those up. You just Google the built-in values. It will tell you what the parameters are. So for time, the value of 1 second is going to be the y property on it, so we'll set that to y instead of z. And I'm just going to times that by, what do we call this? It was normal speed. So normal speed of x times normal speed of y. Z, and then the final property, the 4th one, is named W, incidentally. Okay. Oops, wrong. Looks like I compile a shader, and I've made another mistake. At least we can find out what it is. Let's reload it. Sure. Let's go up this time. 9:28. Okay, what have I done? Typo in here somewhere. Just quickly take that out just in case. That's what my typo is. Okay, so that's our first one. So the typo is on this line. Now let's just have a look and make sure I've got everything. Let's put up map 2. I forgot to declare the second texture sampler. Okay. So we haven't used the second normal yet, but we actually need to look up how to combine normal maps. Now Unity do it in a particular way, so we'll just go Unity 3D, combine normals in shader. We'll just quickly look that one up, what the preferred algorithm is, because it's not just simply an add or a multiplication if you want to do it accurately. But maybe what we'll do is we'll just simply do 1 times 0.5 plus 0.5. That will do for now, but we will want to play around with this, get the actual accurate one potentially. longer run. For now, we should be able to drop in a second normal slot and change the speed. Okay, so I'm going to add animated materials here, just so we've got this preview on. I'm going to grab this small wave, so I'm going to drop it in here. Okay, so now we've got those two. Now this one I'm going to set the tiling to 8. 8. Okay, here we go. Now we got something interesting. Now the speed and things that this goes at, you've got it at 1 and 1. What did we have this one on? That was the 20-second animation, and it moved, I think, to, what was it, 4, 3, -1, -2. So there's a 20-second animation. I think we can just input, so that was 4 divided by 20. I think I can do that. Yep. 3 divided by 20, -1 divided by 20, -2 divided by 20. Okay. There we are. We're getting a better result. We're almost at parity with the original. We've just got to do the depth testing, which is going to be a little bit of a fun exercise, but we're slowly but surely making our way towards a nice looking water system. So we begin to ramp up the smoothness. Now, what I like in the Unity standard shader one is it's actually got a different transparency mode called transparent. It's different to fade. I'm just going to quickly test if we can do this, because I think that we can actually use the same mode here just by changing the alpha mode from fade to trans. If not, I'm sure that we can look it up. Unrecognized parameter alpha transparent. Okay, 1 second. Unity 3D alpha shader. Surface shader directives. Let's pull up the surface shader details, and this will give us everything we want. Incidentally, the Unity documentation on surface shaders is quite good. Okay, so we've got yep, so we use pre-multiplied alpha, so that's alpha pre-mul. That should be equivalent to what we get out of the standard shader. Okay, so I'll start playing with the transparency. Okay, that's perfect. Again, not quite ready for what we want, but sort of getting there. And this should respond to the metallic parameters and things for. So I usually set up that. That will bring them. This is a bit too strong. One thing you notice, I don't know if we can pick it up in the video quite so well, but when you get smoothness values approaching 1.0, you'll get sharp little artifacts across your thing. Never get it to quite 1.0. If you leave it down a little bit in the high 90s, you'll get better quality results. You won't get so many sort of random pixels, especially when you've got moving normal maps like we do with this particular texture. Now, I actually don't like this water texture that's sort of got slapped on here, so I'm going to strip it off. We're not quite close to getting our ideal colours and things yet, but we'll get there. We might play around with a bit of the fades and things to get exactly what we want out of this. Okay, so one of the neat things that this one is doing that we are getting out of that we're not getting in here is this depth fading. So as it gets further away from the surface, the more transparent it's getting. So we'll try and implement the same feature. I'm just going to have a look at exactly how the old one works, and then from that we should be able to derive what we want. So if we take a look at here, we've got I'm sure we've got a depth sampler somewhere. We're just trying to figure out where it's sampling the depth from, and then from there we should be able to get some interesting values. Okay, so the water edge blend, that's where it comes from. So we're using sample depth, that's a Unity function. That comes in through the Unity built-in shader functions, and we just need to pull that up. I think there is actually an expanded version inside this water occlude, if I'm correct. Let's take a quick look. Okay, don't, but let's. So. Linear depth, and that's going to be the key one. So we're just going to do this inside the surface shader, and hopefully this won't all break and we have to fix it. So the first thing first, we'll have the depth. Now that depth, I believe, is specified in meters. If we look up the function linear depth, it should give us the details. So yeah, so that will return the depth that we're looking for. Okay, alright, next steps. We've got the depth value. What do we do with it? Well, first things first, I'm just going to make sure we've got the depth value, so I'm going to use it to alternate the red colour. So we'll look at the albedo, we're going to add, in fact I'll do it on the emission. O.emission equals float 3, we'll do it on the red, depth 0, 0. And now I don't know how this is going to look, but it'll probably turn bright red as the first. Nope, not even that. Let's have a quick look and just make sure we've got these functions declared. So shader. Yes. Yes. Okay. Line 1. Just make sure. Camera depth text. Yep. Yeah. Camera depth texture is not declared. So I believe to use this we do need to declare a few things. Okay. This looks fairly. This is updated a little bit. It's in Unity 5, so we'll go through the new method. It's just going to require a second to learn exactly what that is. So first things first, we're just going to grab the Unity includes. I know it's coming out of the water include, but we'll just include it again for safety's sake. We will add Unity transfer depth to the Vertex Shader. Now, how do we do this with the 1 second, sorry. Camera depth text. I'll just check if that's actually pre-declared. I think it might be. Yes. Okay, so I'm just going to grab a sampler for the depth texture. I believe it's always declared. Yep, fantastic. Okay, so that should actually work with what we've got here already. No, I still do not have a IDA screen pause. Okay, so I do not have a screen position yet either. Now to get that, we just need to declare it in part of the input. So we'll just add a float. I believe it's a float to screen pause, if I'm correct. We'll just add that. Update that variable name. We still don't have it. Hang on, 1 second. One thing after the other today. Just make sure I've got those. Screen pause is coming in. Oh, it's a float 4. Some of these ones have magic names. You sort of have to have a perfect memory to remember exactly what they are, but at least they're only one Google search away. Okay, here we go. So now our depth texture, it's writing the depth values into the material. I don't know if getting further away. No, this should actually be just in meters, but it might be too high. Let's just grab our water, and we'll just drag that down and see what happens. Okay, we might need to do some conversion values on this, but let's see how it goes. We do at least have our linear eye depth there. Just divide that by 5 just to see if we get a value out of it. I'm not quite sure exactly if that is in meters. Now I'm suspecting that it's not. So we might need to tweak that a little bit. Welcome to the fun of shaders. Okay, so linear eye depth. We'll just take a quick look for that one. When in doubt, Google. Sorry, it looks like I just lost my connection. Convenient time, but I still have not completely solved this one yet. I believe linear eye depth is the one we're looking for, but I'll just should return what we need. So let's take a quick look at the Waterfall Shader and see if we can get up with how that one's been used there. So just look at the linear eye depth is used there. They use an edge blend based on the fade parameters. So they do something with the screen position. That's interesting. That might be the missing factor there. So we'll just go for. See how this looks. Okay, so where is that declared? Nowhere else. I see. Okay, so we'll just grab the whole thing. Let's pull it over into our water shader. At least we know I've got this working now. Okay, now they've got fade parameters, which we're just going to copy as well. No point in reinventing the wheel. So we'll just grab that one. Short distance scale. Okay, grab those over the top. And this was just a float for. Okay, now they're using the edge blend factors to modify the overall opacity of the surface. Now, because of the way we've got this set up, I'm using PBR. Just modifying the opacity alone is not going to do the job, which we will see. That might be my fault. Yep, missed one. So to get the values, I believe we needed to lower the metallic and lower the opacity at the same time. So what we'll do is we'll just take that and modify both these values. So we'll just multiply that by that, and we'll multiply the alpha by that. A bit of luck, we'll now have our depth blending shade. It might still be red, but oh, whoops, let me clear that off. Mistake. in doubt, let's remove things until it behaves. Wait. Now saying that I've put something else up. Okay, bring this all back. Okay, so there we go. Now we should get a similar effect to the other one, I think. If I am doing this correctly, where it leads, yes it does. So you'll see there, for instance, see how it's now getting a little bit less transparent when it's near the surface. So we're getting closer. Okay, so the next things we want to do, we'll give it some colour to start with. This is always a bit of a tough one, but find our reference image. Works in places, works maybe not all places though. So what we might do is use a gradient map, and I'm just whip one up in Photoshop really quickly, which is going to determine sort of our depth functions and how the colour is tinted. And I may or may not have activated my Photoshop on this machine yet. Hopefully I have. Okay, great. So I'm just going to make this one 64 pixels long and 4 pixels high. Come on. Now the reason we're doing this in a texture is because it's going to give us the ability to actually declare a gradient properly. We could do it in making various colours, but frankly it's not going to work very well compared to doing it in a gradient lookup texture, which is exactly what we're going to do. So we're just going to create a gradient layer, set that to 0, and now we can start specifying colours. Now I had a reference image somewhere, which I believe was here. I'm just going to bring that into Photoshop as well. Okay. Now, what I'm just going to do is I'm going to use this to sample textures. Sample colours. So just grab the gradient thing, set that back. Set our gradient. Should be 100%. Okay, so on the deep end, we are going to grab from there. And we're going to have a fairly sharp transition, so I'm just going to put 2 there. And I'm going to sample from there. And then finally, for here, we'll go through from that. Okay. Finally, I'm just going to take dither. Okay, finally. Okay, so there's our gradient map. This will hopefully influence the colours of what we're doing based on depth. So, where's my waterfall? I'm just going to bring this into here. Call this one depth. Depth gradient. Now, when we bring this into Unity, there's a couple of things we want to do. First is, because this is basically sampling pure colours, we may not want this to actually be sRGB sampled. That means that we don't want linear lighting things applied to it, because it's basically a lookup texture. So I'll untick that one. And finally, I will also set the wrap mode from repeat to clamp, and that means that it won't wrap around on the edges, which means really low or really high values should just stick to the corner that it's closest to. Now, like depth gradient, we need to do a texture sampler for this. Similar process to before. What we do is we just grab the, to make a sampler for it. So call this depth. Call this depth text. Just declare the sampler. Finally, we're going to do a text lookup. Now, we're going to do the text lookup based on the these values that we've produced based on the depth stuff. So to do that, we're just going to cut and paste the declaration for this one. I'm going to grab it here. Now instead of UV coordinates coming in off the model or anything else, we're just going to artificially produce these. So we're going to go float 2, and then it's got the X is the actual color gradient, and the Y-axis is neutral. So to do that, I'm just going to go edge blend factors.x, and I'm going to set it to 0.5, just for producing half the texture. I'm not going to multiply this by the color, but I'm going to call this one called depth text. Now, where's our albedo? So just going to move this below here. I'm going to go times depth text.rgb. Now, I don't know how this is going to look, but it might be interesting to see. We've got another issue. That one. Mr. Bracket. Okay, here we go. So now the deeper that gets, the more it should move towards the darker colours. But unfortunately it's not quite showing as much as we would like it to. And the reason for that might be that it's getting transparent towards those ends. So what I'm going to do, I'm just going to quickly knock out the transparency, just for now. Knock out that change. Let's just see how that looks. If it actually is influencing enough. And it could be that the values it's shifting towards are too extreme. The other thing I'm going to do is I'm just going to remove the color from this. So set the color to white. Let's see if we actually get any influence. No, we don't. So while we were seeing that on the alpha, it may not have been enough here. Oh! Let's see the RGB depth text. Oh, really dumb mistake. I apologise for that. I forgot to put the texture into the actual material. Can't see myself doing that one. Okay, so now we've got the depth texture in the material. Let's have a look. Yes, so we can see that it actually is beginning to tint the texture the closer it gets to the range. Now, I'm going to grab that material again. Set that to half. Now we've got this going in the wrong direction. Two ways we could fix this. One, we fix it in Photoshop, we just reverse the texture, or alternatively, in the lookup here, I just put 1 minus. 1 minus. Now, is that getting too close to shore? Have I actually not gone the other way around? I hope not, but I'm just going to multiply this by a value to try and stretch it out a bit. So I'm going to go for 1, 2, 3, 2.5, just to try and get the color blend is more dramatic. What I might do is I might just duplicate you. I think there's a saturated range on here, if I'm looking at this correctly. Yes, there is. So there is actually a finite range. What we can do is we can remove that, copy that actually. So what I'll take here and I'll copy that into a new value which we can use for this. So edge. And by using this one instead, we can play around with it a bit. Okay, so this one will give us the unclamped values. This means it will go off the edge, but that's what we're looking for. Yep, so that's what we're looking for now. So as it gets closer, it's getting in. So let's see what we can do about making that a little bit more extreme. 0.5, that might not be extreme enough, but we can play around with this. So as the water gets deeper, the water will get darker. Finally, we're just going to bring back our transparency changes, the ones we just commented out while we're doing the testing. And it's a starting point, but hopefully a useful starting point for building a replacement water shader. Might not be quite strong enough. We might need to play with these few of these variables and things and the base colors to sort of get the results we're looking for. So our reduction in alpha might be a bit too extreme. It's always a bit of a mixed bag exactly how we build this. Now there's one alternative way to, instead of using depth as we have right now, which I'm going to try and quickly do. I know I'm running into my office hours as I typically do here, but one of the final things we can do is now sampling this on the eye distance. This has a problem. The biggest problem is that it's based on based on a straight line pointing from here in the center of the screen down into the pixel. That means if I'm looking at it sideways, the distances are different to how I look at it other ways. Now that may or may not be what you're looking for. Here I don't particularly like the effect, so there is another way of doing it. And we could actually even blend between the two effects as we get more advanced. So the first thing I'm going to do is I'm going to add a new float parameter. I'm going to add this as water height. Change it from a range property to a float. Set that to 5, I guess. Now in the input we can also add a float3 world pos, and that's actually the position in the world. And what we could do is, instead of calculating this based on the depth texture, which is what we've done, we could calculate it simply on the pixel's world position. I guess technically our Vertex Shader is also producing that that value as well. We could potentially grab it from there, but here we go. We will go O dot emission dot equals. We're just going to again use our red to signal what we're doing. Float 3. What did we declare that? Water height as? I didn't declare a float for it as well. So float. So in.world.pos.y for the vertical coordinates minus the water height base 0. So we're just going to saturate that again. Now we could use this for altering our transparency, which is probably the preferred way of doing it. So this one, I don't know if we're going to, yes we are seeing it here, so immediately we've got you can see that we're using the actual height to change it. Now this might be a better way if you want to sort of do things that way. Now it won't completely calculate the depth, I guess, it'll only calculate the actual position of the vertex, but something to think about as an alternative. Nonetheless, this is a starting point, I think, for a PBR water shader. There's probably some values and things we need to tweak, particularly on the color. I don't know what I'm doing there, but and that transparency is too weak, so we might just, last thing we'll do is the edge blend factors. We'll go saturate. We'll go 3. Now saturate just means clamp between 0 and 1, so the value will never get below 0 and never get above 1. There we go. That might be a bit closer to what we were looking at in our reference image. As you can see, this is what we're going for. We've ended up a little bit greener, but that's probably because the input colors I've got due towards the green end of the spectrum. So as we play around with this, we could get the kind of values we're looking for in our water shader. Kind of there. Poke around with it as you will, but that will give you the advantage of a PBR water shader. Now the real test is going to be on the day-night cycle. So if we grab the day-night cycle and we poke around with it, here's how we act at night compared to the original one. as you can tell, it sort of has the full lighting properties and responds as you would expect it to. So hopefully that's a useful tutorial. People can sort of get a handle on something interesting, and I will start my office hours just now. Thank you all for watching.